All right, Stephen, we mentioned it at the top of the show, but I want to make sure that everybody knows, this week is Amazon Web Services reInvent. If you're in Vegas, you know this because it's taken over everything. It probably has more space taken up than the F1 race. And just like every other show that we cover here, there's been a lot of big announcements that have been coming out of it. A lot of people on stage holding up chips and semi trucks and snowmobiles and you name it. We wanted to have a closer look at a couple of these because they're near and dear to our hearts, and they also don't involve chatbots. So the first one is that Amazon has announced that they will be using NVIDIA's NVSwitch technology to create new rack scale AI platforms. So this allows someone to take something like NVIDIA's Grace Hopper and build something using that, which is kind of like the de facto AI standard right now. Or they can use Amazon's AWS Nitro DPUs along with Elastic Fabric adapters to build those. Do you know what Nitro and Fabric adapters don't use? InfiniBand. They use Ethernet instead, which I thought was kind of an interesting move. But here's the thing. We know that AWS has designs on getting into the AI game because they don't want the other companies who are sending all of these rack units out to be making all the money. So how does this play together, especially when you look at some of the other announcements, Stephen?
Well, it is interesting to think, isn't it, that AWS now has one of the biggest, if not the biggest, NVIDIA supercomputers out there. This is really next generation stuff. I think that it's important to recognize that this is based on the latest and greatest technology that NVIDIA has to offer. They are absolutely leaning into most of NVIDIA's technology, including the Grace and the Hopper, including NVLink, which allows all of these devices to talk to each other in basically a massive multi-processor configuration. The estimates on the size of this thing are just unbelievable. It's not clear to what extent it's up and running, but I would say that this is going to be really an exascale supercomputer running in AWS, focused around basically NVIDIA-bound workloads. So on the face of it, basically we've got a beautiful announcement for somebody like Jensen Huang to come out on stage, which he did here at reInvent, and announce alongside the Amazon AWS team, and everybody looks great. But as you point out, there's a few nuances here. One of the nuances, of course, is the fact that it uses Ethernet instead of InfiniBand. That's interesting because basically everything else they're doing leans so far into NVIDIA's technologies. I have to give a special shout out to a great article over the Next platform, which really goes through this. We'll include the link in the show notes. But it points out that, for example, it appears that high bandwidth memory is really the whole ball game here. Basically, having a system with just massive amounts of memory is what allows this thing to perform as well as it does. And frankly, it's going to be interesting to see how this plays alongside Amazon's other offerings. As you mentioned, AWS also announced their own Graviton 4 and Trainium 2 processors. Those could be seen as competitors for Grace and Hopper, of course, along with Intel and AMD. So, basically the news here is that AWS is going to have an AI supercomputer, just like their arch rival Microsoft does in Azure, being the host of the popular OpenAI ChatGPT.
And I think one thing that needs to be kind of pointed out here, kind of you mentioned it, NVIDIA has been using InfiniBand for a very long time because they own it. It came over in the Mellanox acquisition, and they're talking about the fact that it's very purpose-built for these workloads. But they've even admitted with their Spectrum X technology that Ethernet is the way that they want to go. And when you talk to the people in the Ultra Ethernet Consortium, Ethernet is the way they want to go too. I think that this is kind of maybe tacit admission from Amazon that they know they'll never beat NVIDIA at the InfiniBand game. So think about it like this. If you want ultra high performance, you're going to be buying it directly from NVIDIA. They're going to drop ship you however many racks that it takes, and they're going to cable those up with InfiniBand. And you're going to write them a really big check, and you're going to cry, and you're going to have your AI system. But if you don't want to do that, if you want to build your own system in the public cloud, Amazon will build it for you. The catch is that you probably won't be able to use InfiniBand because it does not leverage existing technologies that Amazon has. This does. If you already have a Nitro DPU in every server and you're already using elastic fabric adapters, I don't need to do any more extra plumbing to make this thing work, which is a huge win for Amazon because they don't have to invest in any new hardware and they don't have to, send somebody down to do some cabling jobs. We just flick a couple switches and suddenly that's running the kind of Ethernet network, ultra Ethernet, it's basically what it is, to connect all those systems together. And it can be elastic on demand however you want. You don't have to write the giant check to NVIDIA. You just have to write a slightly smaller check at least 12 times a year to Amazon to get that money back. And I think that is the way that we're going to see this going forward. Microsoft may be an exception to this because of their heavy investment in OpenAI. They're going to use whatever OpenAI needs. But I think with Amazon, they're basically going to say, if you want InfiniBand, you're going to have to go to somebody else. If you want to use Ethernet, we're the horse that you want to run with. All right, Stephen, you mentioned two of those new chips, and I want to take a minute for us to kind of talk about them. The first is Graviton 4. It's the latest generation of Amazon's ARM processor. It has 50% more cores and 75% more memory bandwidth. It's based on the Demeter Neoverse V2 core. So that's the first one. The second one is Trainium 2. This is their AI processor. It has up to 4x performance increase from that first generation that they built about 3 years ago. It also can be liquid cooled, so that should tell you how hot this thing is going to be. It's designed to be deployed in clusters of 16 chips. So I think that Amazon is using Trainium as kind of a workload generator for all of this new NVSwitch stuff that they're doing. What do you think?
Well, I'd say that Amazon is covering the bases here. Let's, I guess, start with Trainium 2. So as you say, there's not a ton of information about exactly what it is. I'm still diving into that. Hopefully we'll have a deeper dive in the future into what this thing really is. But I think it's safe to say that Amazon is hard at work on a competitor for NVIDIA, which is, of course, we just talked about, powering their new AI supercomputer. AWS has their own supercomputer as well, based on Trainium. They say that it's up to 4 times faster than the first generation Trainium, which seems credible. They also say that it's the fastest solution for training models in the cloud, which is an interesting thing for a company to say when they also have their own have this NVIDIA supercomputer out there. Okay. And they're going to be making this widely available to customers. I think that may end up being the difference. I think that the NVIDIA Grace Hopper Superchip system may be less available, and the Trainiums may be much, much more widely available. At least that's how it's been so far with the first generation Trainium processors. So I'd say that all of this shows that Amazon is really keen on delivering their own in-house chips. They're not going to be just relying on NVIDIA as a provider. And I think that that's, kind of to be expected. When it comes to Graviton, we've got Graviton 4 here, as you mentioned. Graviton 4 has twice as many cores at 96 cores. It appears to be a chiplet-based system with 2 chiplets on it. It appears to use the 4 nanometer TSMC chip manufacturing process, which is incidentally the same manufacturing process used by NVIDIA for their Grace and Hopper. And it also uses the same Neoverse V2 cores that NVIDIA is using in the Grace Superchip. So, but I don't think you should confuse Grace and Graviton. Grace is really a support chip for the Hopper AI processors, whereas Graviton 4 is a general purpose compute platform competing with Intel x86 and AMD in the cloud. And just like in the AI and training and GPU space, Amazon is trying to cover the bases here. They are going to offer a nice high performance Graviton offering based on ARM, or they're going to offer x86, or they're going to offer AMD, and they would probably offer something else if there was something else that customers wanted. They're interested in basically giving customers a wide variety of choices here. I think that the interesting thing, honestly, about Graviton is that it's not a huge step forward, even though it is specs-wise a nice step forward. It's not going to be a huge step forward in terms of technology. Essentially, this is a shrink, it's a doubling with chiplets. It's a nice move forward for the Graviton line. It's not a revolution, except when it comes to memory bandwidth. It does have quite a lot more memory bandwidth. And it could be that Amazon is going to be doing things like having multi-socket servers that have much, much more memory. If that's the case, then we could actually have a news story here. But otherwise, I think that Graviton 4 looks like more good stuff from Amazon.
Yeah, I would agree. All right, Stephen, one more announcement we wanted to talk about. In the data space, AWS made news with the GA of Bedrock, which enables customers to run foundational ML models from companies like Anthropic, Meta, and of course, AWS itself. But many companies are worried about hallucination and want to include their own data in these models. And that's what AWS is delivering with something called guardrails. It's what AWS partners are leaning into. Stephen, what's the deal with guardrails for Bedrock?
Yeah, I think that as you mentioned, AWS did announce Q, which is a chatbot, but we're going to steer clear of that. Let's talk about Bedrock because it's more relevant to our audience. Bedrock allows you to run ML models from a variety of sources in the cloud and integrate them with your own data to some extent. Now, I actually did an interview with a company called Click that integrates with Bedrock and allows you to absolutely pull in enterprise data, build custom chatbots based on publicly trained models that really have access to your own information. Very cool stuff. And it's on the lips of basically everybody here. I keep talking to people at the show about machine learning, and they're not talking about, oh, I wish I had a better chatbot. What they're saying is, I wish I had essentially a artificially intelligent intern that I could ask about my company's data that wouldn't make stuff up. And that would be nice, wouldn't it? So AWS is leaning into that as well. Guardrails is actually a really smart product. Essentially, it allows you to restrain the worst tendencies of your ML models. So you can say, for example, here's a set of topics that are off limits. Here's a set of words that are off limits. You can say, here's the data that you have to use in order to make your judgment. You can't use whatever data was baked into the training to begin with. And again, this is very smart. Now, I don't know how great this product is because, of course, it's new and it'll take a while for us to really see where it goes. But it's the right idea. Essentially, what we need to take AI to the next level when it comes to ML models is we need the ability to incorporate our own data and to build custom versions of these things and to steal Amazon's trademark name here, guardrails around those things so that they don't hallucinate, so they don't go off the rails, and so they don't go, bringing in data that we would rather not have these systems use. I think that it's going to be important for customers that are implementing machine learning, especially generative AI, to put guardrails around these models, because otherwise they're just going to have more egg on their face when the models do stupid stuff.
I like that point. And I'm thinking back to a presentation we got earlier this year in May from Juniper Networks at Mobility Field Day 9, where they were talking about the fact that they were going to build a system using AI, their Marvis AI, but in a GPT kind of, chat GPT kind of interface where I can ask it questions. But they don't want it to pull in stuff from the internet because that stuff could be wrong. What they want is to only go through the database of, known issues or things like that just for their system. And they want it to return answers that are correct or not return an answer at all, as opposed to what I have said is the chat GPT method of salesmanship. I don't care what the answer looks like as long as I give you one, even if it's completely, totally wrong and I made some stuff up. So I think that those guardrails are really important because it, A, tells the system to only use these data sets, B, tells it to return answers that are factually correct, and C, keeps people from mining data using your chat interface. And if you don't think folks can do that, all you got to do is Google prompt engineering, and you can find very creative ways to ask a learning system to send you information it shouldn't be talking to you about. Every time someone types something into a chat GPT interface and gets a response that says, I'm not allowed to talk about that for X number of reasons, they will immediately then try to find a way to coach the system to give it that. Could you imagine what would happen if it suddenly started spouting out personally identifiable information? you, would go nuts, and so would the press. So I like this idea of saying, here's what we're going to work on, here's what we're going to build, and here's all the things you're not allowed to do with it. Asimov has his 3 rules. I think this is probably going to be, 3 laws. This is going to be a little bit more than that, but I think it's important to kind of get that foundational aspect in there now as opposed to later. All right, that'll just about do it for this episode of the Rundown. I know there's a lot of things going on, and there's a lot of information coming out of reInvent. And Stephen, I know that you've talked to a lot of companies that are there at reInvent. Where can people go to see some of the stuff that you've created?
Well, I've been producing short form videos, including interviews and just thoughts from the show. Check out the Gestalt IT video YouTube channel for those, or find us on LinkedIn. I think that's a great place. But also stay tuned to Gestalt IT, because we're going to have some deep dive interviews and articles coming out from Haiku, from Click, and from Skyhawk Security next week, based on projects that we've conducted here at AWS reInvent.
All right, Stephen. Well, thanks for that. And I know there's a lot of great stuff that's been coming out, and I can't wait to dig into it as well. Something else we're digging into is the event calendar for 2024. That's right. We're getting close to the end of the year, but that doesn't mean we're going to stop. In fact, we're going to keep going right on forward with our first events in 2024. And Stephen's up with the first event in 2024. What can you tell us about it?
Well, end of January, January 31st, February 1st, we've got Cloud Field Day. That's right. We're returning to the cloud, and we are currently selecting our delegate panel. It looks like it's going to be an all-star panel with some of my favorite folks joining us, as well as some great companies signing up for that. So stay tuned to Tech Field Day's channels for more announcements.
Speaking of returns, I'm very excited to announce that I will be returning to Amsterdam for Tech Field Day Extra at Cisco Live EMEA 2024. I could not get enough of all of the great stuff, and Lord knows my Stroopwafel collection is finally starting to kind of taper off a little bit. But thankfully, we're going to be hearing great presentations from our friends at Cisco, along with a few other companies, and you're going to want to stay tuned to our website at techfieldday.com to find out more about them. We're also going to have a great lineup of delegates. We're going to be focusing on a variety of topics that you're not going to want to miss. And for those of you who are not going to be able to watch live because you're not up at the crack of dawn Amsterdam time, we will be publishing all of those videos to our website and also to our YouTube channel at youtube.com/techfieldday. So if you're like me and can't sleep, you can watch it live. If you prefer to get your beauty rest and would like to catch the recordings, we'll have those available as well. And then, Stephen, after that, you've got another big event coming up.
Yep. I am very thrilled to announce that AI Field Day is returning February 21st and 22nd. We have a very big announcement to make very soon about our anchor company for AI Field Day. We're partnering with our friends over at the Futurum Group on this event as well. And I can't wait to see what comes out of our AI Field Day. Again, we're going to be bringing together a great group of people. Unfortunately, no French fries with mayonnaise at AI Field Day, though you'll probably get some at Cisco Live.